Now let us take the question number 41, which says that if an operator A cap is Hermitian, then the operator B cap, which is I A cap, is what? Whether it is Hermitian or anti-Hermitian or what. Right? So let us try to understand this problem. So if A cap is Hermitian, which means that A cap equals to A cap dagger. Right? This simple Hermitian operator property. Right? Now this is what? Transpose conjugate is the Hermitian. Now let us take B. If B is I A cap, then B dagger is equals to I A cap dagger. Right? So which means it gives you minus of I A cap dagger. Right? Now remember that A dagger equals to A. So B dagger equals to minus of I A cap. But I A cap is nothing but B. Right? Which is minus of B. So it means that B dagger is equals to minus B. It means that it means the operator B is anti-Hermitian. Right? It's a simple problem about the properties of operators, which in Hilbert space, right? So operators are matrices and they follow the properties of matrices. This is a simple question and simple answer, right? Let us take a problem on parity operator, which says that which are the following statements about the parity operator are correct, right? The first is that parity operator P cap is anti-Hermitian. Second is P cap is unitary. P cap is equal to unity operator, and the eigenvalue of P cap are plus and minus 1. Now let us try to understand one by one. So if you understand it fully, so parity operator is not an anti-Hermitian rather than Hermitian operator. So P cap is P cap dagger. It's a Hermitian operator. That everyone must always remember. Now P cap is unitary. Yeah. It means that P dagger is I. Right? So it has unit value. It means that mod P square equals to I. Right? Which gives you P as plus minus I. Right? It has two values. So it means that it has unity operator, and its eigenvalues are. Now it is equals to unity operator, right? And if you calculate the eigenvalue, it has P cap operating on psi gives you plus minus of psi. This is what it does. It changes the sign. Now if it is x is there, then it goes to minus of x plus minus of psi. Right? Sorry. So it gives you psi of minus x, which gives you plus or minus of psi x. So it gives you eigenvalues as, so p psi equals to e psi or lambda psi, where lambda is plus minus 1. So the properties which are correct are unitary equal to unity operator, and the eigenvalues of p are plus minus 1. It is not anti-Hermitian rather Hermitian, right? So these are some of the properties of parity operator, and if any of them will come in the exam, you will be able to answer it, right? Let us go to one more problem. Let us take this problem number 43, which is about calculating the trace. It says that consider the state psi, which is 9I phi 1 plus 2 phi 2, and chi, which is minus of 1 upon root 2 phi 1 plus 1 upon root 2 phi 2. Where phi 1 and phi 2 forms complete orthonormal basis. Then find trace of outer product of psi and chi, right? Let us, this is called outer product. Let us try to solve it. Outer product always gives you a vector, right? So this is given as, first let us try to find psi and chi. So what is psi? So this is psi and chi is nine I phi 1 plus 2 phi 2 right, and then chi, which is Hermitian conjugate of this, will give you simply minus of 1 by root 2 phi 1 1 by root 2 phi 2, right? Remember that this is just the outer product. So this is giving you, this gives you column vector, and this will give you, right? Now let us try to multiply it. When you will multiply, this will multiply with both of these, and this will multiply with both of this. Remember that phi 1 and phi 2 are orthonormal. So phi 1 will go to phi 1, giving you minus of 9I divided by root 2 phi 1 phi 1, right? And this one gives you two divided by root 2 phi 2 and phi 2, right? I think, just a minute. So here it is I by root 2, not, right? So I by root 2, so it gives you 9I with 9I square, so giving you 9 divided by root 2 phi 1 phi 1 plus 2 divided by root 2 phi 2 phi 2. Right? So what is the trace of this matrix? This is a matrix. The trace of the matrix is sum of the diagonal elements. Now here are only diagonal elements, which is phi 1 phi 1 phi 2 phi 2. Now other diagonal elements which will arise are phi 1 phi 2 and phi 2 phi 1, but they are orthonormal bases. So it means that their product will be 0. Right? So this simply gives you minus 7 divided by root 2, and this gives you 9 9i and this, right? So 9 I is I square is minus 1 multiplied by 1. This gives you 9 divided by root 2, and this gives you 2 divided by root 2. Others are 0. The cross diagonal elements. So what does it gives you? Sorry, here is a mistake. So this is the complex conjugate we are taking, so it will be positive. So here it will be positive, giving you minus. So 9 minus 2, so trace will be trace plus 2 divided by root 2, giving you minus 7 divided by root 2 as the trace, right? So you take the matrix multiplication and you sum the diagonal elements to find the trace. This is one simple question, and it's very, very useful, and as it appears in most of the exams, GATE, NET or JEST or tifr or iisc or all sorts of physics, PhD or MSc entrance exams, right? So it will be useful for here. Let us discuss this problem number 44, which is find the commutator of this A, B, C, D, B, C and D. So let us solve it. So it says A, B, C, D, which can be simplified as BC minus CB and D, which can be further simplified as E cap BCD minus CBD, right? Now you have two commutators, and one is this one and another is this one, right? Now you can simplify it. You can write it E cap, B cap, C cap, D cap, and minus B cap, C cap, D cap, and A cap, and minus A cap, C cap, B cap, and D cap, plus C cap, B cap, D cap, A cap, as the minus between in the bracket will be basically multiplied without minus in the sign. So this is what you will get. This is how you calculate the commutator with multiple commutator sets, right? So commutator inside the commutator. This is a very significant problem, which is quite frequently asked in most of the exams, right? Here, so let us discuss this one, this problem, which talks about the norm of a vector. So it gives that given that v equals to 4 plus 3i, v1 minus 4 exponential of minus of 3i pi by 2 v2, where v1 and v2 are orthogonal pairs of kits, then the norm of v is what, right? Let us calculate the norm of B. So to calculate the norm of B, first we calculate the bra corresponding to this kit vector and then take the inner product. And whatever you will get is basically you will take as the root, and that will give you the normalization factor. Right? This is the standard procedure of finding a norm for the vector. So let us calculate the kit. Now B will be gives you 4 minus 3i v1 minus 4 exponential of 3i pi by 2 v2. Right? Now to solve it, now you have this kit now, bra now. Now take the inner product. So it gives you 4 minus 3i v1 minus 4 of exponential of 3i pi by 2 v2 and this h 4 plus 3i v1 and minus 4 exponential of minus 3i pi by 2 v2. Right? Now take the simple matrix multiplication to calculate this. So it gives you 4 minus 3i, 4 plus 3i is a square minus b square, 16 minus of 3i square. Right? And this minus will become plus 16. Now the exponential terms will cancel out and you are left with 1. So how much it is? 16 plus 9 is 25 plus 16, giving you the 41. Right? Now the norm is what? Norm is the root inner product. This is nothing but root 41. So this is the norm of wave vector, taking the inner product and root of that. Right? So if you divide it by this value, the each vector will be normalized. It will, right? So this is all we have. This is another very important problem related to the normalization, how to form orthonormal vectors. Right? So this is all we have today. We'll come up with more number of problems on the other topics in upcoming class. Please stay connected.